Hi, Keith here with another short video tutorial. This time I'm just going to talk a little bit about beyond-BACI designs and some of the challenges associated with analysing them and deploying them in practice. On screen here I've got a diagram illustrating just about the simplest beyond-BACI design. Now remember, a BACI design involves samples taken before and after at the control and impact site. So specifically, one set of samples before, one set of samples after, at one control and one impact site. Now, what I've diagrammed here is a design which involves taking samples twice before and twice after at one impact and two controls. So each of these dots here represents a time when replicate samples are taken, and each line is a site. So that is control site 1, that is control site 2, and the solid symbols here are for the single impact site. So it's beyond-BACI in two aspects. There's more than one control site, and there's more than one set of samples taken at each time before and after. And remember, the point here is a set of replicates, however many might be taken. Altogether, you can see we've got 12 sampling times, 6 sampling times before, 6 sampling times after, a total of 12 sampling events. Multiply that by however many replicates are taken each time. So if it's 5 replicates, then it's 60 samples in total. Now, one of the things that beyond-BACI designs enable is much more comparisons, or many more comparisons. Now, what I've done here is replace the dots for sampling times with text. So here, before one simply refers to taking the samples at the impact site at the first sampling time before, and after 1 and after 2, here and here, refer to the samples at the impact site after the impact has occurred. And down the bottom here we've got the same thing for the two controls. Now each arrow here is a comparison that can be made, and I'll explain a couple of these just to give you an idea of what I mean. One comparison is, for instance, to look here and compare samples taken at before time 1 and before time 2 at the impact location. And if there is a significant difference there, that means there's some short-term change at the impact location before the impact. And that comparison can be done for the control sites and for all sites after the impact. In the case of after the impact, it's going to tell us about short-term change after the impact. Now, because we've got two control sites, we can also do comparisons between those. So here we're comparing control 1 and control 2 at the first sampling time, and then at the second sampling time. And again, because we've got two control sites, we can calculate averages. So this arrow here is really talking about looking at the averages for control site 1 and comparing them to the averages for control site 2 before any impact occurs. This is doing the same thing after the impact. Average of control 1 compared to average of control 2 after the impact. Now, of course, there are many more comparisons going on in here, but it's not a whole lot of point in going through all of them. Most of them actually have nothing to do with impacts. So all of these comparisons here before the impact occurs are not telling us anything about impacts, though they are telling us things about the control and potential impact locations. All of the comparisons that we can do afterwards may also not tell us much about the impact. One thing that we might get out of there is if there's a difference after the impact in short-term changes. For instance, the controls stay the same, but the impact site decreases in abundance or diversity, or shows some other sort of change. However, the critical comparison is the comparison of before to after. So before, after versus impact control. It's the interaction between the change from before to after in terms of the behaviour of the impact site and the control site. Now, that arrow there is indicating a comparison of the impact site before and after. That arrow there indicates comparison of control 1 before, after. That's control 2 before, after. This one here is the average. The average response of the controls from before to after. So what we really want to focus on is a comparison here that compares the change in the impact location to the average change in the controls. Say that again. The change from before to after in the impact versus the change on average at the controls from before to after. And we're concerned with the average of the controls because any individual control site might be a little bit strange. So by using multiple control sites, we compensate for any potential oddities in control locations. That's also the reason for doing more than one sample before and afterwards. It's to, first of all, to just add replication and ensure that we're not drawing conclusions based on a few odd replicates. It also gives us the opportunity to look at short-term change and see if that varies from before to after. Now, how do we go about analysing this? Well, in simple terms, we can break it down into three factors. One comparison that's obvious is the comparison from before to after, the BA. So that's looking at the average before comparing to the average afterwards. Now that test itself doesn't tell us anything much about the impact because it's averaging over all sites before and all sites afterwards. So it's only telling us whether or not there's been a change. It might be that all sites show an increase in diversity or abundance afterwards, or a decrease. Another comparison we can do, or test we can do, is looking at the individual sampling times. So in analysis of variance terms, the sampling times are nested in before and after because we've got two particular sampling occasions before and they don't really match up in any particular way to two particular sampling occasions afterwards. It would be different if we focused on specific seasons. So we focused, for instance, on the wet season, the dry season before, and the wet season and the dry season afterwards. If, however, there's two more or less haphazardly or randomly selected times, then it's nested. And the analysis of variance convention is to put the nested term in brackets. So times is nested in before and after. Now all that test is doing is telling us whether there's short-term change before or after. Again, it doesn't say anything much about impacts. The third main effect we can test for here is among locations, or as I usually say, among sites. The terminology I'm using here, incidentally, is adapted from Underwood's paper. So I'm using something similar to his terminology. Now that's a comparison of the average impact, average control 1 and average control 2. So again, it's not telling us anything about impacts, it's just telling us whether there's a difference on average among the sites or locations, and there might well be. The critical one, and the one that we really need to focus on for impacts, is this one here. Before after times location, or before after by location. That's an interactive effect. And what it's testing for is, do the locations show the same behaviour from before to after at all locations? If there's no significant effect there, then essentially all three locations or all three sites are showing exactly the same behaviour from before to after, and there's no evidence of an impact. If that is significant, there may be an impact. Oops. Why maybe? Because this is looking at all three locations, and it may be that one of the controls is behaving oddly. So it may be that the impact location and one of the control sites show exactly the same behaviour, but control site 2, for instance, has done something strange. So to interpret that interaction in more specific terms, we actually need to go back to a graph or table of the means and look at how the individual sites are behaving to see if it looks as if from those results it's the impact site which is showing strange effects or doing something unusual. We may also need to pursue other tests to be more clear about that. The last thing we can test for here, times nested in before and after by location, is testing whether there are differences among locations in short-term change before or after. So if that's significant, it means that either before, after, or both, at least one of the sites is behaving differently from the others. It might be all three are behaving differently. Degrees of freedom over here are calculated in the usual way. So for a main effect, for before and after, it's just the number of levels take away 1. So we've got before, after, that's 2 levels, take away 1, gives us 1 degree of freedom. For locations, it's not a nested factor, so it's just the number of sites or locations, take away 1. When we look at nested factors, however, it's the degrees of freedom for the nested factor multiplied by the number of levels of the factor they're nested in. So putting that again, before and after, in each of those two periods we have 2 sampling times. So that part there is 2 minus 1 or 1. And before after itself has 2 levels, so basically we've got 2 times 1 or 2 degrees of freedom for that. The interaction degrees of freedom are just calculated by multiplying the appropriate terms together. So before after by locations should be that by that, which is not that. So, sorry, mistake there. That one is correct. And these down here are calculated from total numbers of replicates. Okay. Now in one of the optional parts of topic 5, we look at Underwood's more complex analyses for beyond-BACI designs. And I'm not going to go through this in detail, I just want to point out specifically what he's trying to do. Now, as I said, with the basic design or basic analysis back here, we don't really have a specific test for an effect of an impact. If the BA by location or BA by site is significant, it may indicate an impact, it may not. What Underwood has done has been to devise more specific tests for impacts. Now, first of all, in his terminology, he just uses B to refer to BA. And I've left that in here to be consistent. So this term down here is really before after by control impact. And he also uses I just to refer to impact, whereas I tend to use IC or CI. Now, up the top, some of these are the same, so that's the same, that's the same, that's the same. Those three are the same as for the simple analysis. What he does then, and I won't go through specifically how this is done because it's complicated and you don't really need this level of detail, but what he's done has been able to break out a whole range of other specific comparisons. So most of these comparisons down here do not appear in the simple design. And what is specifically being able to break out is this one here, which is a direct test of the impact. It's a interaction between before and after, and a comparison between impact and average control. So if that test is significant, it is a direct indication that there has been some kind of impact. The impact locations differ in behaviour from before to after to the average controls. And as I say, that's not something we can do with the simple analysis. One of secondary interest is down here, because that looks at the behaviour after the impact and compares the impact again to the average control. So, well, that's the main test of an impact. This is really a test of after effects. Basically, is the impact location after the impact has occurred still showing different behaviour to the control, or has it settled down in some way? For instance, if that was significant, it might indicate that the impact location was showing a continued decrease or increase in whatever was being examined. Now, I won't go into how the degrees of freedom here are worked out, but they are essentially worked out the same way, and the bottom ones down here don't actually change, nor do these ones here, because they're really coming from the original simplified analysis. What Underwood has done is used a method to break out a whole set of other comparisons. Now, in doing this, he's created an analysis which is quite complicated and quite complex to do. It's well beyond the capabilities of most people who are familiar with analysis of variance. That is, most people who are actually familiar with analysis of variance. I can do these, but I'd have to go back and read all the detail, and it would take me quite a long time to do one particular analysis. Part of the reason for that is there's no simple way to get all these comparisons out of a statistical package. Typically you have to do a set of analyses and juggle the results around. In many cases, it is simpler to run the simple analysis here, and then if the before-after by location or before-after by site interaction is significant, pursue that with other tests and other comparisons, including graphs. In absolutely critical situations, we might look at doing this analysis. But as I say, it is complex and not for the uninitiated. Okay, more generally about beyond-BACI designs. What are their advantages and disadvantages? Well, they give you more informative results. We've got more information coming in, so that's going to tell us more about what's happening. Because we're looking at a set of controls and a set of times before and after, we can draw more reliable conclusions and do better tests for impacts. There are a couple of other points down there that you can read as I'm talking. There are, however, some problems. As I've just talked about, they're not simple to analyse, and doing an analysis of that particular design is really something for an expert to do, whereas the simple analysis of variance can be run on most statistical packages and is relatively easy to interpret. There's also difficulties in implementing them in practice. Obviously, we're increasing the amount of sampling that must be done, and increasing the number of controls makes it more difficult to find appropriate and representative controls. So they're practical issues. And there's also issues involved in justifying the cost, because again, you're increasing the sampling. And the more sampling that's done, the more the cost increases. From going from a design with one impact and one control to one impact and two controls, you're obviously increasing the sampling effort by a full 50%. So that's going to have a significant effect on the budget. The other thing is that when you go from one impact to 2 controls or 3 controls, an increasing amount of the budget is being spent away from the impact location. So if you've got 3 controls, 25% of the budget is spent at the impact location and 75% somewhere else. And it might really be a bit difficult to justify that and convince people that that's a worthwhile use of money. One way around that is to have greater sampling replication at the impact with less at the control, so that the amount of budget balances out. Now, there are some modifications and alternatives. So the most common design that's done is really often referred to as an MBACI. It usually has several sampling times before and afterwards, though that might be limited to 2 in many situations, but it does have multiple controls, 2 or 3. So typically that will be 1 impact location, 2 or 3 control locations, and sampling at 2 or 3 times before and afterwards. There's no attempt, as in some of Underwood's designs, to have multiple spatial scales or multiple temporal scales. So it's really the simplest kind of beyond-BACI. A second type of design that's commonly used, particularly for stream and river communities, is the BACI or BACI paired design. And the pairing comes in here because there are paired sampling sites or paired locations. So if we take a river, of course it flows downstream, and if our impact location is here, any impacts are going to be felt primarily downstream. So we can set up an impact location down there and a control location up there. And we can do this on the impact stream and on a matching control stream. Now, the impact down there is not really an impact site because there's no impact going to occur down there, but what we end up having is a set of nice comparisons. These controls can be compared, and that impact and that control location can be compared. So you can get a very good handle on what the impact might be doing in the stream system. And if we can have multiple impact and multiple control locations, control streams, even better. One reason for using this design is that each impact stream has impact and control, and this helps us compensate for the fact that streams are often very idiosyncratic systems, and one stream is not going to be exactly like another due to differences in flow, hydrology, geography, and so on. Okay, I hope that explains a bit better what we're trying to do with these beyond-BACI designs. In practice, the 2 that are most commonly used these days are these: a slightly expanded BACI design with multiple controls and multiple sampling before and after, or some kind of BACI design which will also have multiple sample times before and after the impact.